We started with our introduction to Pythagoras, and I dealt with the concept of when you have the hypotenuse or when you don't have the hypotenuse. When you don't have the hypotenuse being the length opposite the 90 degrees, then you will add, but when you do not have it, then you will subtract. Right, now today, as we follow our mind action series, the layout always works in such a way that the work example explains what to do. The exercises are based on very similar examples as example 1, 2, 3, and 4, perhaps even 5 on page 182. If you've done that, then exercise 1 will be very similar to that. Now, likewise, exercise 2 will be very similar to example 6 or the use of the converse theorem of Pythagoras. And by the time we get to exercise 3, we'll deal with a little bit more intricate aspects using Pythagoras, but the extent of work will be slightly more. Then also we deal with our revision exercise, and the revision exercise is laid out in such a way that, for example, on page 188, exercise A would be a revision of quickly working out X, exercise B, C, perhaps a little bit of converse, and then onwards we work with our application. Now at this stage I feel that we can maybe dive into some applications, so I've chosen 2 out of your revision set, just because my book is the different edition, my ebooks. I've chosen the 2. It's not F and G in your books, however, it is I and J. So I'll be doing those 2. And then I thought I'd do one like this, where we work with our lengths in terms of an unknown, an X value, right? So some of our more challenging shapes will perhaps have a length in terms of X, but I'd like to do one just so that we know how to approach it. So for your understanding, this number F and number G is in fact from the revision exercise on your page 188 and 189, and this one right here is in your books number I. The instruction is also slightly different because this is from the revised version, and then this would be number J. So just to correct that. Right, so if you see the shape, you'll see it's similar. So why did I keep my Pythagoras theorem handy here? Is because I will revert back to what we started with, but we will also see sometimes we'll have to combine our properties of quadrilaterals as well. So that's very important that we also bear that in mind. If we just move this here. Okay. Now, what we'll start with is looking at what properties of a rectangle may be used in order to help us calculate a certain length. Now this length, bear in mind, when you learn to use Pythagoras, you've only learned that it exists in a 90-degree triangle. So always try and look for that 90 degree, find it, and ask yourself, I can only start with it if I've found my 90 degrees. So when I read this question, I read that PQRS is a rectangle. Now with PQRS being a rectangle, in your book, in I, it's called ABCD, okay? But the strategy behind it will be similar. Now calculate the length of the diagonal. Okay, there's the diagonal QS. It's been labeled QS. And in your book, they'll go one step further. They've actually indicated another diagonal in question I. And then they go one step further by asking that you actually work out the length of a part of it. So what we do know then is that diagonals bisect each other in a rectangle. So I did upload a nice summary for all of you just to share here. I uploaded a little summary here just the other day so that we are also able to apply those rules and we can see here okay, so tips for quads, that's the one I'm talking about. And here I've just put together a little summary also from your mind action series, and your tips for your quadrilaterals come in handy when you need to prove using this specific property. So we're busy with a rectangle. So in order to prove that a quadrilateral is rectangle, we will need to prove this, this, this. This would be when we have to prove that there are certain quadrilaterals. Please keep this in mind. It's there for you to use, okay? Going back to the whiteboard, we're going to attempt then to just first find out what the length of QS is in this stage. So very similar to your question I in your book. And I'm going to first start by saying, great, in rectangle, because that's what I've been given, PQRS, what may I add in terms of properties? What do I know? Okay, I know that in a rectangle PQRS, all angles are 90 degrees because that is a property of a rectangle. Therefore, I have to first find the 90 degrees. Remember now, we can't start with anything unless we have that 90 degrees. Therefore, I'm going to make the statement that in triangle PQS, angle QPS is equal to 90 degrees. And therefore, triangle PQS is a right-angled triangle. I'm just writing this here for my own purposes, okay? Why do I need to do this? It's because I want to work out Pythagoras. Sorry, I want to use Pythagoras. I want to work out that length. So let me just copy that one over here. And then we can get the picture that we're looking at. Great. Here we go. Okay. What's important now is the fact that I've indicated my 90 degree. That's very important because it means I can go ahead and apply my theory the way I want to. So I've got angle P, I've got angle Q, I've got angle S, and I've got a length here of 84 meters, and I have a length here of 80 meters, right? So knowing that that's been given, I'm able to just check. I think perhaps in your version, they did not indicate the units that you're working with. This could be meters, it could be millimeters, it could be centimeters. Don't worry about that. All you need to worry about is to remember to write it within your answer, but to use what you've just learned. We've done an introduction to using Pythagoras. So using my theorem of Pythagoras, I can say that length QS, why is that one so important? It's because it is opposite my 90 degree. Therefore, QS, I will be able to work it out using Pythagoras. QS squared, let me just set up what my triangle's lengths are, in what order they'll be. Why am I saying QS squared is equal to? Because it is the hypotenuse. According to the Pythagorean theorem, C squared will be equal to A squared plus B squared. Let's just remember that, okay? So I'm making the statement in this triangle that QS squared is equal to, and I'm going to say PQ squared plus PS squared. Why may I make that statement? Because I've already established it's a right angle triangle, And whose statement am I using? I'm using Pythagoras theorem, okay? Theorem of Pythagoras, right? Which means I have already concluded these at 90 degrees. So remember now, if you want, just add in which angle is your 90 degrees. Remember, you may not make the statement if you didn't have that 90 degrees. Now let's carry on, and we say, okay, I'm going to say QS squared, because that's what I want. I've been asked to work out the length of the diagonal, which I colored orange there. And I say, okay, I'm going to substitute my lengths. And I've got PQ is 80. And then I've got PS is 84. And then I want to just go one step further. I don't want to use my calculator just yet. I'll use calculator. For this one, I'll use a calculator because it's rather big. But I will only use this when I've written everything down the way I want it. And that would be QS is then the square root, okay, of 80 squared plus 84 squared. So it's not just a question of working out. It's a question of doing it in an effective way, okay, where I'm doing this on my calculator quickly, and I want to work accurately. So I want to encourage you to first write down, first make sure what you type into your calculator is written on your page. Then you type it in for the marker, okay? And I'm going to say 80 squared under the square root. I've got that one squared equals, and I get a final answer of 116. So it takes me straight to the answer. I've already taken the square root to get rid of that squared. And I presume you're with me, because what we do to the one side, we have to do to the other side. Hopefully you're with me there. And this is meters. Okay. So what can we do to take it one step further? With regards to your question in Mind Action series, they do ask to prove that the one length is equal to the other length, or that you need to find the one length. I'm just going to highlight it here. So let's say that we've been asked a question after that, the second part, to prove PQ or S. Let's just call this O. You need to determine the length of PO. Let's say that was asked. So if I have done all this work, then I can say that QS is therefore equal to PR. Why may I make that statement? That statement is based on the diagonals of a rectangle that's equal. How do I know it's a rectangle? It's because I read my question from the beginning. My question from the beginning gave me all the information and the clues. Therefore, I may make that statement because PQRS is a rectangle. And what does it mean? It means that the diagonals of a rectangle are equal. Okay? What else do I know? I also know that the diagonals of a rectangle also bisect each other. What does bisect mean? Bisect means that PO will be equal to OR, as well as if I take QS, QS is halved into QO being equal to OS. And if that's the case, then I take QS and I simply just halve that measurement, because at the end of the day, PO is equal to OR, which is equal to QO, which is equal to OS. And if I say QS is equal to 116 meters, my 116 divided by 2 gives me 58 meters, which is going to be equal to QO, which is also OS. So that's all the same length, but I want PO. So therefore the length of PO sorry, this one must be PO here. So the length of PO will be equal to 58 meters. And that's all based on these theoretical aspects, just to take that one step further. So once again, we're combining our knowledge about two-dimensional shapes. Now let's look at this one here. This would be number J, letter J in your revision section. And it looks like it's similar. DEFG is a rhombus. We must know the properties of a rhombus. EG is 16 centimeters, DF is 12 centimeters. Calculate the perimeter of DEFG. Right, what I need to do here is I need to look at what I have to kind of zone into to find the perimeter, okay? What we do know about a rhombus, so there are several things that we can say about a rhombus now, right? Is that we may perhaps just look at those diagonals first. So let's zoom in a little bit and let's see what can we take from this. If it's a rhombus, then I should know, knowing the properties, that the diagonals of a rhombus, what do they do? The diagonals bisect. Diagonals of a rhombus are also perpendicular. So that's a really, really important thing there. And what I'll do here is I'll just make these lengths are all the same, right? These are the same lengths. These are all same. But what I do know is that a rhombus has that 90 degree right there in the middle, okay? So take all that away and I can make life easy for myself and I can go straight to making the statement that within the rhombus, diagonals are perpendicular, okay? So let's add that here. We are going to say in rhombus, why? How do I know it's a rhombus? Here's all my evidence. This is a rhombus. I'm allowed to use the fact that this is a rhombus. Sorry for that, I've moved it. And I can say, great. Let me go to DEFG is a rhombus. What theory may I use from that? I may say that in rhombus DEFG, diagonals, let's name the diagonals DF and EG, are perpendicular. Okay, the fact that they are perpendicular gives me a clue to a 90-degree angle. That means that angle DHG, because remember what we said, we can't apply Pythagoras if we haven't got a 90-degree angle. Where is DHG? DHG, there we go. There's my 90-degree angle. Why am I doing this? Why am I doing all this work? I'm doing all this work because I want to find the perimeter. Always remember, go back to what you want. You want the perimeter. Why do you need this if you want the perimeter? It's because we want to find the length, right, of DG, as it will be the same length as EDE and the same length as EF and the same length as FG, because properties of a rhombus state that they're all equal in length. They're also two sets of parallel sides. And also, I know that my diagonals bisect. Okay, let's take that one step further. We go to EG. Now, EG, this is the whole of EG is 16, okay? Take it back, which means that length is going to be equal to that length. That's the next statement we'll make. I'm going to say that EH is equal to HG, which I can just halve that. It's 8 centimeters. Why? Because the diagonals of my rhombus bisect. okay? Why? Because I have a rhombus. All my theory comes from that statement. Next, I can say that the other diagonal, let's look at the other diagonal, let's make it green. DF is equal to 12 centimeters. What does that mean? That this length will be equal to that length, okay? So let's make that statement. We then say that DH is equal to HF, which is equal to half of that, which now will be 6 centimeters. Also, because my diagonals of this rhombus bisect. You may be as precise as you need to be. There we've got that, we've got that, we've got that. So let's take that little triangle. We've got it all sorted out now. We have enough information about this right-angled triangle. And I'm going to quickly just draw it here for myself to work in it. And I'll see now I've got everything in place so that we can apply Pythagoras, okay? The whole process is to build the steps necessary to apply Pythagoras. So always remember, you're looking for that 90 degree, okay? Now, what I have here, my 90, what I have here, we say DH is 6. And what I have here, we said that HG is 8. I ask myself, do I have the hypotenuse? No, I do not have the hypotenuse, therefore I will add. So you can go straight to using c squared here. C squared is equal to a squared plus b squared, just because it's nice to start off your formula, knowing that you're using the theorem of Pythagoras. Once again, let's give this guy credit. It's an amazing theorem that he established here. Therefore, let me substitute. I want c squared, what is this in this case? dg. dg, right. So let's call it dg because I want to find out what that length is so that it can help me with my perimeter. dg squared is equal to, you can choose A or B here, that doesn't matter, 6 squared plus 8 squared, right? What did I say just before this when we did the previous example? Sort it out first. Sort it out first, right? That's going to leave you with DG. This one you could possibly do 36 plus 64. Oh, maybe this is one of those triplets I was talking about the other day. Right, you will have certain triplets that always exist. Therefore, DG is equal to 10 centimeters, okay? Now, why is this so useful? It's because, back to my question, I want to find the perimeter. Why am I doing all this work? It's because I want to find the perimeter. And now I may use perimeter of a rhombus is equal to 4 times side. That side is my length. It's not because it's length times breadth. That's not what it is. It's because all sides are equal in length, okay? Therefore, we go straight to saying DG is equal to GF is equal to EF is equal to DE. Why am I making this statement? It's because the lengths of a rhombus, sides of my rhombus are all equal. Okay, great. Now I can finish it up. The perimeter is equal to 4 times 10 centimeters. Perimeter is equal to 40 centimeters. Perimeter of what? Okay, perimeter of what? Perimeter of my rhombus. You may add that here. Perimeter of rhombus. Perimeter of rhombus, DE, FG. Great. Right, so that was that. Just a nice example of using your properties. And then The last 5 minutes, I'd like to do this other one here, just so that we don't get scared when we see stuff like this. Maths is easy if you apply your theory, and it gets easier the more you do. So practice, practice, practice. Firstly, I'll ask myself, do I have a 90-degree angle? That's my big question. Do I have a 90-degree angle? Yes, I do. It's right here. Right. Because angle C is equal to 90 degrees, I have a right-angled triangle, okay? The fact that I need that right-angled triangle is very important. ABC, sorry. So I'm going to make the statement that C squared is equal to A squared plus B squared. Why may I make that statement? Because I have a 90 degree and because Pythagoras is going to work here. Theorem of Pythagoras. Why? Because angle C is 90 degrees. That's your complete reason, okay? Just because we also want to test whether you can assess, is this in fact a right angle triangle? Now, what do I have here? Okay, I have a length expressed in terms of x, okay? So what I'm going to do is I'm going to just replace C, okay? I'm going to say C squared, right, is equal to A squared, right, plus B squared, okay? I'm still going to stick with my original. C squared is equal to A squared is equal to B, okay? Now I'm going to find out what is C, okay? Let's color code. C is x plus 7, okay? That goes there. A, what length is A? A is 5, there we go. And then what length would B be? Let's find that. If my highlighter can work faster. There we go. That would be B. So let me write within those brackets the colors that I've chosen. X plus 7. A is 5. And B is X plus 6. Now, why is this such an important section? I wonder. Because there are certain products, rules of products that we have learned, especially with these two statements here. Right, so certain things in maths exist, laws exist, that allow us to work accurately. And some of these laws are sometimes confused, okay? So we are not allowed to say, watch out here, we are not allowed to say that this is x squared plus 7 squared, which is 49. That is so wrong, okay? This bracket squared means that you have a bracket times a bracket. So please, I'm doing this so that you can watch out for algebraic techniques here. Similarly with this bracket. And now we apply that foil, dolphin leap, Garfield face, whatever it was that we wanted to apply. We do that now so that we can work accurately, okay? And I'm going to say, I'm going to do my technique where I go XX, 7, 7, middle, outer. 7x plus 7x is 14x. Is equal to 25. I'm treating this like an equation. XX, 6, 6x inner plus 6x outer, 12x. Let's solve this. This is nice stuff. So now I can carry on here. Let's try and get everything to one side. So we actually we would like to just sort things out. Now what I see here is I have a positive x squared here. I have a positive x squared there. Okay, so the positive x squared carry over the other x squared is going to give me 0. So I don't have to stress about that. What else do I have? I have a 36 here, a 25 here. So for the sake of leaving my higher x coefficient on the positive side, let's leave 14x here and let's carry over. 14x, let's go fetch the other x. Okay, minus 12x, okay, is equal to whatever I have left here, 25 plus 36 minus 49. Okay, now 25 plus 36, 25 plus 36, and we have a minus 49, and that's 61 minus 49 will leave me with 12. Okay, and then I have 14x minus 12x leaves me with 2x. Inverse operation, how do I undo multiplication by 2? I divide by 2. What I do on the left-hand side, I do on the right-hand side. And therefore, x is equal to 6 centimeters. Let's go and test it. Don't just leave it. Don't throw your pencil down and walk away. Test it. Maths needs to be tested. We need to validate our answers. Verify, is it correct? If we say that x is 6, is it possible? Well, knowing what we've learned from the whole idea of a right angle triangle, this length right here, the hypotenuse should be the longer side of the two, which means if I insert 6 there, I'm going to get 13 centimeters. I have my 5 centimeters here. If I put 6 in here, I get 12 centimeters, and great. That really fits because the hypotenuse is always longer than the other sides. And that's that. Some algebra together with Pythagoras.